Hello, everyone. And in today's webinar, we'll be going through what is generative AI and all the hype and talk about what is AI and why people are more interested and thinking AI is going to be the next boom in the technology world. And so just don't take by the news. I'll be just sharing what all we are finding in the why is generative AI so popular and why people are more bullish on AI and what it can do for humans and the technology, how it will shape up the technology for the future. Okay, so uh, before understanding what is AI, let's see why AI is becoming a hot topic. Yeah, so there are so before understanding what is generative AI or AI in whole, uh, if we see what is the current why are people investing so much on AI. So the projection for AI currently is like around $100 billion US at present. Just in the matter of 5 to 6 years, it's going to be like a 20x. So if somebody is investing in AI right now or understanding what is AI and how AI can help us in future, so that is why just to follow with the trend and everybody's prediction about the market cap for AI is around like $2,000 billion in next 7 years. So seeing this tremendous opportunity, so everybody is saying this is the golden age for AI to boom and make the life better for everyone. And so that's why all the AI technologies is in boom. So before jumping into what is generative AI, let's just understand the history of AI, where it originated from, and and what all has happened over the period of last 70 years. So in the initial years around 1940s and 50s, uh, there was person called Alan Turing, and they conducted a test like can machines do human computation or human job, and that is often referred to Turing test. So Turing test is an example or a process in which they will try to do a job a human can do. So that was the initial spark, can we replace humans with machine? So in early 40s that was done. And during the same phase, neural network models were built. Uh, so neural network models, how they were thinking of was how human think, how all the questions they were forming as a network. During 1950s to 70, uh, that was the time of AI coming in. Till then, it was just testing and everything. Then what they were thinking was, can we build an intelligent system capable of reasoning and problem solving? So they were trying to give so many scenarios to the machine. Okay, what if it if somebody's that time there were logic boards and all. They will be giving some operation and operation or XOR, that kind of steps they will be building, and they will be trying to solve a problem. And during the same time, the natural language processing programs were developing. But the problem was there were so many combinations to be solved. The computation power was very less. It was not like we are having so many like gigabytes of CPU, GPU. That time it was around like KBs only. So the possible training or learning of all the possible outcomes was very slow. So that's how it began in 1970s. Then there was a phase of 10 years where it's called the first winter for AI, because all the funds were dried up and all the processes were getting slowed. The attention or interest of the people were getting down because the main challenges were like there are so many possibilities, and with that possibilities, getting result and having a flexibility and scalability was getting bottleneck. So the everything was slowing it down. Then during the 80s to 90s, that was the rise of machine learning. So a lot of techniques, what we see right now, CNN, or we call it decision tree, or support vector machines, or Bayesian network, all were developed or rediscovered during this phase. So this all the algorithms or all the techniques were being built during this phase. During the 2000 and 2010s, that is the time where it was rise of from normal computing to parallel computing. GPU based machines were coming in. There was rise of neural network, NLPs, and reinforcement learning was there. And so this was the time where the computational, the bottleneck, like uh, the challenge what they were having during the 80s was computational power was low. So if there are like 100 billion combinations, it used to take 10 years. Now it was like around 6 months or 8 months of time to train or run through all the combinations. So just to give you an example how it was, how GPU has like excelled the development in AI. So this is an example of GPU, how it is processing your request or your data set. They are just speeding it up. So this video or demonstration is from NVIDIA. So this was like consider 1980s, how the computation was going on. Then they have developed a GPU system. That's it. Now you have like so much computational power, like within fraction of seconds, you are getting a Mona Lisa painting done. So you can understand like these guys are running in a slow motion camera, but the power of computing, how that has boosted the AI industry or AI world because of so many like it has cut down so many time, so much time. So the acceleration of this phase has been a huge boost to the AI industry. Now let's just understand like the modern era of AI. So what's happening in the modern era? So in 2018, they developed the GPT-based model for pre-trained transformers. Then 2019, that came 2.0. Till then, it was just gathering all the information from the internet or public data source and trying to answer or generate text based on the public data source. Then around like 2020 3.0 came in, and 3.0 was a boost because it was having a technique called few shot learning. We will go in depth into that. What is few shot learning or zero shot learning? Then Web GPT, then Instant GPT. So this transformer based techniques for generative AI has opened up a wide range of use cases for the industries they can use on that we'll be discussing on the later stage of the webinar. But this transformation has been done in just like 5 years. And all this has been possible because of the compute or what you call GPU based system that we have got in the last 10 years has made it all possible. So if you consider last 70 years of progress has been accelerated in last 5 years. So that much potential everybody is seeing in. So understanding and learning AI and applying it to your or day-to-day services, it's the next big thing or the golden era of the AI is coming in. Consider this is still the golden era. You have not seen what Google and other companies are building in. So future, if you see the system or the quantum computing system, what they are building in. So what you saw that Mona Lisa painting is taking half a millisecond or second. So this, if you just see what kind of system the Google and everybody are developing, so within the next 3 4 years, it can do all sort of computation within minutes. So much high-tech computable system they are developing, and these are run through so much coolant, like because a lot of heat will be generated and all. It's like if you get time, you should see this quantum computing system by Google. So they are just like, it will blow your mind what kind of investment they are putting in. It's just a short clip I'm just putting in here. So these are some of like reasons why everybody's so bullish. Like the figure what you have seen in the first slide, like $2,000 billion business or industry will grow in next 7 years. Like this has been backed by what all development all the big companies are doing. Where Meta is doing something on all the field, from Meta AI to their metaverse and everything. Where Nvidia is working on building models, or the Google is working on building their compute machines and models. So yeah, so that is the main reason everybody is so attracted towards it. So this was like why one should be doing generative AI and what was the history. So now let's just understand what is generative AI. So in generative AI, there are two things. So if you tell a machine, make a decision about X. X can be an image, a text, anything it can be. So it can be any kind of a dimensional vector. So you just ask a question. If you feed a document or an image and tell or ask it what it is. So what it does is it generates you an answer. So that's like classification of whatever input you have given, and it's just giving you answer for based on the classification. The second stage of generative AI is generation. Like you tell it to generate something for you, like an image or a summarization essay or a text summary. So there are two things. You tell it to identify something or you tell it to generate new things. That is what is generative AI all about. So there are like few, I have just put on like few generative AI techniques what is been used in the current. So first one is like generative adhesive network. So it has two neural networks. One is called generator, where it creates new images or text, that model, and the second one is called the discriminator, where it compares it with the real data and then it determines it is real or fake. So this is mostly used for images, image generation, or image based processing. Then we have one more technique called variational autoencoders. So in this technique, what it does is it compresses the data, whatever data you feed in or whatever you want, it compresses the data, then it trains into a unsupervised like algorithm or training, and then it generates new images. So in this technique, what is the advantage is you are getting more control in while generating your images. And again, the application is for using images and data compression. The most widely known generative AI technique is called transformer, all the GPT based whatever UI or whatever application you see, it's all based on the transformer based technique. So what it does is it's just a decoder. Like you just ask GPT. So what it does is it generates a sequential text, a context or sequential text. And the main technique what it does is it rely on attention mechanism. It just like this decoder just looks into the context and relation between the words and sentences and then other data points and builds a paragraph or a blog, or you can say summarizes you anything. And the main application built around transformers are like chatbot summarization or translation of text to text. Then other technique is called diffusion model. So diffusion models, what they do is they remove a lot of noise from your image or your training phase, and it produce high quality images. And these high quality images are built using textual description. You just give them a story or text, it will like create an image for you. So the next big step, what generative AI they have developed is called like few shot training or zero shot like problem solving technique. So few shot is like you just give it a few context. Okay, like I'm staying in India. I want to. go to NVIDIA like workshop or conference. So you are giving step by step steps and you tell it to do some task. Okay, give me the like a best schedule or something. So it needs some steps. And if you see in the example what they are saying, uh, they are doing in two languages. One is English and one is Spanish. Whatever you are saying in English, it's first we have fed some examples. Okay, like whatever you are saying, we are saying staying in India, so it says I'm staying in India in Spanish. And then you ask a question, then it replies in the other language. But in zero shot problem solving, you don't give any reference or example. You just say a sentence and tell it to convert it. It will do it for you. So like there was no pre-training or a few steps of learning for the model. So this after this, it has been like more rapid development has been made on the GPT side. Then again, we have other multimodal generative AIs like text to image to image, text to 3D, text to speech. These are other kind of models that we have. Now let's just go through the use cases of generative AI. First of all, like I've just listed off few of them. Healthcare. Healthcare, it's a very big, we can say like they have a big advantage or like a big scope because the computation or the combinations of all the data what we have, if we use that, it can be used for drug discovery. Like they can have so many combinations of it, they can try it out faster and there can be more better result, and they can use for analysis also. In biology they can try all the genomics, like all the like they try to develop some cross genes or understand the genes, because genes have like so many millions of data, so it will be useful in that also. And protein structure, how to look into the protein structures of all the animals or everything, it can help us out with that. In robotics, it can be used in planning how we can build a robot or a whole system. In geoscience, we can be using for forecasting, for prospecting, for sensing what can happen by feeding it a lot of data. In marketing, we can use it for personalized text and images. In agriculture sector also we can use feeding it a lot of data, then having robotics and sensing applied to it. So so everything will have some challenges, so this generative AI also has some challenges. So whatever data that we feed into generative AI, they need in some pattern called instruction and solution pair. If we can provide in that pattern, it's easier for it to understand. But to create that kind of data, not everyone will be an expert. So there are few techniques that have been working on the AI, like supervised fine tuning or reinforcement learning. So these are using these techniques, you don't need that pattern of instruction and solution together. They learn by themselves, and also by unsupervised learning and handling them, we can overcome this challenge of giving it instruction and solution pair. The other challenge of generative AI is like in the current world is, if you train generative AI on biased data or a wrong data and you expect it to give you a correct answer, then right now there is no system, because what you train in, the same output. If you put garbage in, there will be garbage out. So it's very much important to give it a clean or clear data, non-biased data, so that it can generate or give you a correct or a optimum output. Then the other challenges what generative AI has is like proprietary and confidentiality. So everybody's data have to be like they need to be private, and to maintain confidentiality with the private data, this is a big challenge now everybody is facing right now, because privacy policies and all, if we just give all our data public, it's gonna be a nightmare for everyone. So all the companies are building around it, and it needs to follow some industry specific norms, like what is going on, how there needs to be a standardization of all the protocols in this development phase. The other challenges for generative AI are like IP ownership. Like if you want to generate some image of a portrait or a art, so does the model have the right to develop it or reproduce it? So these kind of challenges, then IP attrition, like output needs to be of proper source. Then this generative AI can be harmful, like if the output are misleading, and also like it can be sometime offensive. So these all are the challenges that all the companies are working on. And so this is an advantage, like a space where some companies can develop prototype according to these challenges and market it. So considering all this, like what AI has been doing in last 5 6 years, there's so much optimistic and a lot of money has been invested in developing this. So so there is a large opportunity lying down the line in 5 6 years. Okay, thank you guys. Hope you like understood this webinar. If you have any questions or feedback, you can ask.
Hello.
Yeah.
Yeah, Vijay. Yeah, it was a very informative session and very useful one, I would say.
Mhm.
So, like you said that there was a first winter
Mhm.
during the early stages of AI
Mhm.
development. So, what do you expect? Like, if I want to start my own company during some in future,
Mhm.
so what you say? Like, will there be any other winters coming, or will there be any effect, negative effect? Mainly, what I want to ask is on the same AI field,
Mhm.
or like we are more secured in terms of that.
Mhm. See, there are two things we should always consider. Like the challenges during the 70s were the computational power was very low. So if you want to train it on some rules or data, it was taking years for them doing that. So seeing that, they were thinking, okay, it's not going to go anywhere because for training some data, it will take years. Then we test it out. If it's not working, again retrain it. It's going to take so much time. So that challenge has been resolved in last 5 to 7 years with the parallel computing and the amount of GPU based system that we have right now. Uh, so that has tremendously boosted the whole AI sector. But if you have to consider, there is like as I said in the last few slides, like data privacy or IP iteration or IP rights. So these are the challenges that all big companies are still facing in. How we can come around that and how we can avoid harmful impact or misleading information. So there are two things right now going on. Some teams are working on developing new models. Some are working some solution that can be a practical solution that can be applied to the real world currently. They are working a safeguarded environment or safeguarded models they are trying to create. So seeing all this scenario and it's like what they say, ride with the flow or go with the flow, because so everybody, all companies are trying to automate or use AI in some feature so that it can increase their productivity or make their process more easy and automated. So I will definitely say uh, start small and see where you can go with that.
Yeah, so it's like we are in still the early budding stage, you can say, in terms of generative AI. There are some of the negatives that you mentioned,
Yeah.
but yeah, it's a very vast source and very, you can say, like most of the engineers are working
Mhm.
on that particular field only. So we can expect more, I think, more advancements in like the next few years, I would say.
Yeah. Yeah.
So, is there any particular cloud services that we can use for generative AI? Are there what kind of cloud services or providers that we can use for the generative AI processing, like training the models and all?
Mhm.
Like, if I don't want to buy, like, these machines are very expensive, so I don't want to buy those kind of machines in on the physical system. So, are there any virtual sources?
Yeah. So if you think, yeah, so this is one more sector that has been booming right now. like there are a lot of companies, they are providing cloud compute services. uh, of course there are big players like AWS, Google, Nvidia. They are providing their compute, or as well as they are providing their models, so that we can use them. And so there are small players also, they are tapping in this environment and creating their own ecosystem, and like they are renting out their machines on hourly basis on for cheaper price.
Yeah, it was great information. Thanks for all the help.
Okay, if any other questions, if not,
Hi, Vijay.
Yeah, hi Vijay.
yeah, guys.
Thank you for taking the time to share your expertise with us today, and we are excited to learn more about generative AI and
Mhm,
how it can transform the way we approach technology and creativity. I would like to ask you a question regarding the same.
mhm.
Can you define some of the challenges, ethical challenges we face with the generative AI, especially in the terms of content creations, so we can keep some what are the majorly challenges you have faced? Is there any challenges?
uh, yeah, like, so I have been using generative AI for like a lot of things, generating text for my content, we say, and say content for my blogs or writing email. So what I have seen is like they put in a lot of more technical words, and so so we have to give it a correct prompt, and sometimes we are not happy with the content, we have to have a follow-up prompt to it, so that it can give you a more desired content what you're looking for.
Okay. Okay, Vijay. Thank you.
Yeah. Okay, guys. If no other question, thank you for joining the session. If you like this kind of content, definitely follow graymatters.com. We'll be having a lot of more sessions based around AI, and yeah, see you again. Thank you, guys.